Welcome everyone. In this video, we will be taking a look at proxying our Flutter application, or proxying the network traffic of our Flutter applications. So there are a variety of reasons you might want to do this. It might just be curiosity, or it might be because you want to debug the network traffic, or maybe you even want to do some security testing. At the time of this recording, the .devtools doesn't have a network profiler, and there are some other solutions that you can look into, and I list those solutions in the companion blog article. So basically tools that allow you to inspect the network traffic. However, all of these tools have some limitations, and essentially they just instrument your application and log all of the network traffic. If you actually want to intercept the traffic and modify it as it is being transmitted and have some dedicated tool to basically capture all of the network traffic, then this video tutorial and this blog post will be useful to you. As what we will be looking into is not just capturing the info, but actually proxying all of the network traffic. And if you're not familiar with what a proxy is, or what a proxy tool is, then I hope this video clears that up. I won't only show you how to proxy your application, but I will also try and explain why it is important to understand some of the underlying concepts of how to proxy an application to get a better understanding of the security side of things. Because once you modify your application in such a way that it could potentially impact the security of your app, it is important to understand what you are doing and why you are doing it. So yeah, I do hope you enjoyed this video, and I do suggest that you read the companion blog if you want more information. In the blog post, I go into more detail for some of the underlying concepts, and I use the video tutorial as more of an explanation of how to proxy your application. That's it, let us get started. So as you can see, I've made this simple example app, and this just sends a GET request, and I am made a local server that just responds with homepage. And then here we have a field that says send message. So currently this is not initiated. I should have seen a client message. I'm just going to refresh this and then explain to you what I'm doing. So yeah, now we get this message that says hi client. So this initiates a WebSocket request to this local server that I made. And a WebSocket request is essentially a long-living TCP connection. And WebSockets communicates in a different way than a normal HTTP GET request or POST request and response. In a future video, I will go into more detail regarding WebSockets because I'm planning on making a video that incorporates WebSockets into a little bit of a game. But yeah, for the purposes of this video, we will just be inspecting the underlying network traffic. So what this WebSocket connection does is if you send a message to the WebSocket, then the WebSocket will just reply with that message. So now, no matter what we send, it will just reply with that message. And what we will be doing is we want to intercept this traffic. So before it gets sent to the server, we want to intercept it, basically inspect the package that is being sent, maybe modify it, and then send it to the server, and then wait for the response to come back. And to achieve that, we will need a proxy tool. And a proxy tool is probably the most important thing that you will need to successfully proxy an app. And there are literally hundreds of proxy tools available. In this video, I will be using a tool called Burp, and there's no specific reason that I'm using Burp, it's just because I'm familiar with it. And this tool also lends itself very well if you do security testing. I'm using the community edition in this video, and that is free, so it's free for anyone to download. But again, feel free to use any proxy tool that you want. Burp might be a little bit overkill, and it might provide too much functionality. There are simpler tools available. So first off, I'm just going to delete these two. And then we will jump into how we can configure Burp to allow a proxy, and then how we can configure our emulator to point to the proxy. So in Burp, you can go to the proxy tab and then options. And as you can see, I've already created two of these same instances. And let's just do it again. I'm going to click add. And this is basically just adding a listening port and a listening IP address. So here you can see we have bind to port. So we're going to say we want this proxy to be listening on port 8080, and then we can use a specific address. So we can use localhost, or we can even use the actual IP address for this machine. So I'm just going to say localhost because everything is local. And what localhost is, it's basically a dedicated IP address just to specify this current machine that we are running on. So we're going to say OK. So we've defined a new proxy listener. So now Burp is listening for any traffic coming into localhost on port 8080. So let's jump back to history. And so now what we want to do is we want to configure our emulator to point to this proxy. So on a normal device, you would swipe down and go to the settings or your Wi-Fi settings, and then just proceed to edit the network details. And then you can see we have this proxy button over here, and then you can set a manual proxy. And here we can, for example, give the IP address and the port that is listening on. But for an emulator, we won't be doing this. We will actually be using the network tools that are provided with the emulator to proxy our application. But if you want to proxy a physical device, this is what you will need to do. And a similar process applies to iOS. If you struggle, just do a quick Google search. There are loads of material to help you with this. But yeah, let's go back to our application. I'm just going to restart. And then what we're going to do is we're going to go to settings. And you can see we have a variety of different things we can configure. And at the bottom, we have settings. And then we have a general tab and a proxy tab. So as you can see, I'm already proxying this application. If we say no proxy, then no proxy is applied. Manual proxy. And as you can see, we have this familiar term localhost and the port number 8080, which is what we defined. So we're just going to click apply. And after clicking apply, it should route all of the emulator's traffic to that proxy tool or to whatever proxy is listening on that IP address and port. Okay, and now if we go back to Burp Suite, we should see some traffic. So as you can see, we have 2 calls to WS, and this WS is essentially the WebSocket handshake. So as you can see, it makes a connection that upgrades the WebSocket request. And if we look at the response, you can see that we get a response of switching protocols and an upgrade of WebSocket. So now we have an active WebSocket connection. So that means if we send a message, for example, hi, and send it, we get hi back. And you might notice we don't see any of these requests. And that is because Burp Suite has a different tab for WebSocket history. So if we go to WebSocket history, there you can see these are a couple of old ones that I made. We sort by number. 9, you will see the message that says hi. And this is to server. So this is what we send to the server, hi. This is what the client gets back, hi. As I mentioned, the server just echoes whatever the client sends. And similar for HTTP. So if we make a GET request, this just sends a GET request to / to the URL that's /, and the response is literally just text that says homepage. And here you can see we have the HTTP headers along with it, and same with the request. Here's the HTTP headers. So as you can see, it is very easy to set up a proxy, but it's only easy because we are communicating over HTTP. We aren't using a secure protocol. And once HTTPS comes into play, that is where it gets interesting. Because the entire point of HTTPS is to establish trust between the client and the server. And it's not supposed to be easy to proxy traffic between the client and the server if HTTPS is involved. Because essentially, if you're not using HTTPS, as you can see, it's quite easy to intercept traffic. And any attacker on the same network as you could potentially trick your computer into routing the traffic to their computer before sending it off to the server. So for the rest of this video, we will be delving a bit deeper into HTTPS and certificates and how we can configure our proxy to also intercept HTTPS traffic. Before we get into that, there are 2 other things that I'd quickly like to show you. In the intercept tab, we can say intercept is on. So now if we send a message, for example, message 2, send it, you will see that we intercept the request. And now we can say message 3 and then forward. And now this is the response, forward. And as you can see, we modified the request in our proxy. So this is a very useful tool if you're doing something like security testing, or if you just want to debug your application and see what happens if you do weird things. And it's a very useful tool to also just inspect what is happening. Sometimes your application might be making more network calls than you were initially expecting, or sometimes it's even making network calls that you weren't expecting at all. So yeah, I do hope you see the benefits of using a tool like this, or I should say a dedicated tool like this. And one other thing or caveat to be aware of is I mentioned that I'm running a local server, and that local server is this one running over here. So it's just a Golang application, and that responds to the homepage request, and it also initiates a WebSocket connection. So as I'm running this on localhost, one important thing to note is on a phone, I'm not sure if this is the same on iOS, it might be a different port, but at least on Android, you don't send it to localhost, because if you send it to localhost, for example, here I'm making a GET request just to the home root. If I'm sending this to localhost, then it will be localhost to this specific device. On an Android emulator, they have this dedicated IP address, 10.0.2.2, that basically routes it to your computer's localhost. So just to demonstrate, if I give this value to be localhost over here, again, that will be the localhost for this emulator. It won't be the localhost of my computer hosting the server. We would need to send it to 10.0.2.2. Or alternatively, give the actual IP address of this computer. But none of that's really relevant to the purposes of this video. I just thought I would mention that. So now let's head on over to intercepting HTTPS traffic. Okay, so to begin proxying HTTPS traffic, we will first explore proxying the traffic from a normal browser. And that is because it's just a little bit easier to visualize and explain some of the concepts. So to achieve that, we are going to go to settings over here and then preferences. So this is Firefox that I'm using. It's a similar process for other browsers. And then in the general tab, we just scroll down to the bottom and then you will see we have network settings. And as you can see, no proxy is configured. And here we have the option to say manual proxy configuration. And again, 127.0.0.1, that is the same as saying localhost. And port 8080. And then we have this little checkbox over here that says use this proxy server for all protocols. And this is to ensure that we also proxy HTTPS traffic. So then we hit OK. And now as an example, let's say we want to go to google.com, we will see a certificate error message. As you can see, secure connection failed. And this is because the browser wasn't expecting this certificate. Once we go into the realm of secure HTTP traffic, then certificates or SSL certificates come into play. And HTTPS is not just a protocol that encrypts your traffic, it's also a protocol to establish trust. And what's essentially happening now is the browser is not trusting the certificate that it is receiving from our Burp suite or from our proxy tool. Because this proxy tool is essentially sitting between the browser and the server that we are communicating with. So to explain that better, let's go back a bit. And I'm just going to remove the proxy. And now if we go to google.com, you will see everything is working. And at the top right here, you can see we have connection secure. And you can see it says verified by Google Trust Services. And we can also click more information. So here's information about the SSL certificate. And as you can see, this certificate is issued to google.com and it is issued by Google Trust Services. So every web application that implements HTTPS, they need to have an SSL certificate. And that SSL certificate needs to be trusted or needs to be signed by a certificate authority. And there are a large number of different certificate authorities. As an example, if we go back to preferences and search for certificates, you will see here are a couple of authorities that are listed or provided by default in the Mozilla Firefox browser. And as I said before, the purpose of HTTPS is not just to encrypt traffic, but it's also to establish trust. And the way that we establish trust is by trusting the certificate authorities. If I want a new SSL certificate for my website, I would essentially make a request to one of these authorities, and Google is one of those authorities. As you can see, if we scroll down here, we should see Google at the letter G, Google Trust Services. So yeah, I can make a request that they sign my SSL certificate. And for that to happen, I would essentially need to give my domain name. I would need to give my business name. I've never actually personally done this, but there is some process involved to this. On a lot of new hosting service providers, for example, Firefox hosting, you don't actually need to do this. They configure an SSL certificate for you. So what you basically need to know is that these certificate authorities take your domain or your SSL certificate, and it says, yeah, this is trusted by us. We verify that this SSL certificate belongs to that domain. So when you make a request to a server and that server sends back an SSL certificate, then your browser checks to see that it is actually in fact signed by one of these certificate authorities. And if it is signed by one of these certificate authorities, then it establishes a secure connection and basically does a key exchange between the browser or the client and the server. And it does that key exchange by using a combination of symmetric and asymmetric cryptography. So in my blog post, if you want more information, I do suggest you read this. Here you will see there's a section called Encrypted HTTPS, and this goes into detail of what is happening under the hood. But essentially what is happening is we are using the certificate that we receive from the server, and that certificate has a public key, and we take that public key and we encrypt a new secret key that we send to the server. And our server is the only server that has the private key associated to the public key. And we take that private key, we decrypt the secret, and now the server and the client are the only two computers in the world with that particular secret. And now because it has that secret, we can use that secret as a encryption key to perform further encryption on our traffic. And from that point on, all traffic between the clients and the server will be encrypted with that secret key. That is a lot. I do suggest you read this blog post, and I'm also linking a lot of other resources that provide better explanations and more in-depth coverage. But the main core concept is that if you see a certificate error in your browser, it means that the browser doesn't recognize the certificate authority or doesn't recognize who signed that certificate. Because you don't actually need a certificate authority. You can self-sign any certificate. Any person can open a command prompt and essentially run the commands to generate their own SSL certificate and then create their own process of signing that SSL certificate. And that process is called self-signed certificates, and we will be discussing them a bit more later on. But what you need to know is that a tool like Burp Suite basically self-signs its own certificate as well. So if we do a proxy, so let's go back and actually add the proxy again. So our proxy is added. Now you can see our secure connection failed. And if we look, inspect here, you can see connection not secure and more information. And basically what is happening now is that the certificate that it is receiving from our proxy tool is not a certificate signed by any of the certificate authorities. So the browser cannot trust it. So for us to overcome this issue, we need to tell our browser that we can trust the certificate that is being presented by Burp Suite. And to do that, we need to go to Burp Suite. If you go to options again, here where we added the listener, you can see we can regenerate CA certificates. So if we click this, then Burp Suite just automatically behind the scenes generates a new signing, a certificate authority certificate. But what we want is we want to export the current one that we're using. So as you can see, we can export the certificate in dir format. We can export the private key, or we can export the certificate and private key in this format that's called PKCS. And PKCS is essentially just a format that, let's go to Google. PKCS is essentially just a format that gives you the X509 certificate along with the private key. And the X509 certificate, these are just some phrases that you don't really need to know unless you're really interested in cryptography. X509 is a standard defining the format of public key certificates. So this is basically just the encryption protocol. And along with this, there are a variety of different standards or file formats or extensions that you can deliver an X509 certificate. As you can see, we have .dir, .pym, and these are just different encodings to encode the data. And by encodings, I mean some might be a binary encoding, and the other one is a base64 encoding that is represented in ASCII. But again, unless you're really interested in security and cryptography, it's not that important that you understand this. You just need to understand the basics, what we will be covering in this video. So if we head on back, what we want is we want to say certificate in dir format. We just want the certificate. And we're going to say next, and then I'm going to select a location, and I'm going to call this Burp Cert. And as you can see, this is in dir format, so we're going to say .der. Just to show you, it said certificate in dir format. So that's why I gave it the extension .dir. The next up, what we want to do is we want to install the certificate in our browser. So we are going to go to settings again, or preferences, and then we're just going to search for certificates, view certificates, and then in authorities, we are just going to go and import that authority. I don't want to minimize that. Okay, so here we have the dir file that we created, and we're going to say open. And then do you want to trust Portuguese CA certificate authority for the following purposes? So we just wanted to identify websites at this current moment, and then beautiful, okay. And then okay, we should have added it by now. And now if we go back to our proxy and we load this again, there we go. Now our browser is trusting the certificate that it receives from Burp Suite. And as you can see, we can intercept the traffic. And let's sort this by request. Here you can see our post request that actually makes a request to search for test. And yeah, if you want to perform web application testing, this is how you would start. Now you have all the requests, and now you can start playing with these fields and look for vulnerabilities. But obviously only if you have permission. Okay, so now that we've visualized it on a browser, the same essentially applies for a physical device or for an emulator. This emulator by default, if we go to the Chrome browser, we won't be able to intercept traffic by default. If it is working, then it's something that I'm doing wrong. Or it's because, yeah, as you can see, we don't have a connection. We currently still are proxying, but we aren't seeing any of these proxies going through. And that is because we haven't added the certificate to the Android trust store. Just like our browser has a trust store, the Android device actually also has a trust store. And I actually believe the Android trust store uses the exact same one that Mozilla provides, like Firefox provides. I might be wrong on this, but either way, when it comes to iOS, when it comes to Android, Windows, or dedicated browsers, all of them have their own little trust store saying we trust these certificate authorities, and the same for a Android device or the same for an iOS device. So to add a certificate, it's not more complicated, but might require 1 or 2 more steps. So it's quite easy to do if it's an emulator. All you have to do, honestly, is drag in the certificate. So as you can see, this is the cert that we made. It's called .dir, and we're going to drag it in and copying files. And I think this should load it to the downloads folder. So now if we go to settings and search for certificate, install certificates, and here we have our downloads folder, and here we have burp cert.dir. And as you can see, this burp.cert is an old one. Do not pay attention to this. This is when I was just going through this by myself. What we are interested in is this burp.dir. As you can see, we can't click it. And that is because we want it to be in the .crt extension. Android recognizes the .crt extension and not .dir. And these two are essentially exactly the same. It's just a different file name. So you might be thinking, I can just use this old one, but this old one is a old certificate. What I did in Android or in Burp Suite, I said regenerate CA certificate. So this certificate is no longer valid. So okay, let's minimize this. And now what we want to do, we want to open a terminal. And I'm going to ADB into the device. And what ADB is the Android debug bridge. So basically to send commands to your running device or emulator that is connected to your machine. So if we do ls, we want to go to the SD card, I believe, and then downloads. And here is our files. Let me zoom in a bit. How do you zoom in? Okay, I have zoomed in. Let me just go back so you can actually see what I did. By default, you ADB shell. And ADB shell gives you a bash shell to the device or to the emulator. and then CD, so change directly into the CD card folder, and then go to downloads. Then ls, list what is available in that directory. And we don't want the burp_cert.cert. We don't want this old one. As I said, it's invalid. And then I just want to move the burp_cert file and then rename it to be.crt. And now we can exit this connection, and let's leave this open. I think I might still use this later. And okay, let's click install. And you would need to configure your device to be or to have a PIN. So my PIN is 1234. If you don't have a PIN, this will prompt you to make a PIN or to make a password. And then you can give it a name. So we're going to say Burp certificate. If I can spell it, I think that's right. And as you can see, we can say VPN and apps. Okay, and then we're going to say, okay, Burp_cert is installed. And now if we go back to our browser and actually go to our Burp Suite, our listening proxy, and we search again, it should work. And there we go, our certificate is now installed. And now you might be, okay, cool, we're done. We are ready. We can do it in iOS. Again, iOS is slightly different, but basically the same to install a certificate. But we're actually not finished, because from Android N onwards, Android has provided additional security to make sure that other applications on the device won't respect the certificate authorities that you load onto the device. So it will only respect the default certificate authorities that are loaded on the device. So if you have a rooted device or an emulator and you understand what you're doing, you can actually bypass that restriction from a security perspective. You can just disable that restriction to allow other certificates to be used. But that comes with a lot of overhead and you need to know what you're doing. That's more from a security perspective or from a hacker perspective if you want to intercept traffic. What I will be showing you now is how you can do basically exactly the same that we have been doing, but only from a source code perspective. So just to prove that this isn't working, if we jump back to our file or jump back to our application and we modify our app to not go to our local server or the app that I'm running, and instead go to HTTPS Wikipedia, and we save it, and let's just do a hot restart. And then open Burp Suite. And now if we do a GET request, it should fail. There we go. As you can see, handshake exception, certificate verify failed, self-signed certificate in certificate chain. So this is exactly what I said before about a self-signed certificate and how anyone can make their own self-signed certificate. So as I said, Burp Suite makes its own self-signed certificate. It's not trusted by the trust store in Android, by all of the loaded certificate authorities that is trusted on an Android device. So what we would need to do is we would need to tell our code to basically respect this certificate authority. We need a way to say, hey, listen, our application, we know this certificate and we trust the certificate. So let's click through these error warnings and basically tell our application that it should trust this certificate. So I've already added the code for this, and it's very simple to do. But before I go into this code, one thing that is important to note, and this is why you should always be careful when it comes to the security of your application, in the blog post, you will see that I also mention a particular Stack Overflow case. I think it's this one. Okay, it's this particular Stack Overflow post over here. And what this says, it says how to solve the certificate verify failed. So that error that we just received. And you will see that a lot of people recommend, although they say it's the bad way or the incorrect way, they basically say just allow all certificates. So here you create or you instantiate the HTTP client. And then for the client, you say a new callback for bad certificate. So when the bad certificate fires, all you say is true. You return true. So what this will mean, if we do the exact same thing now on our application, we will basically tell this application to accept any certificate. That will be the same as using HTTP. because if it accepts any certificate, it means that anyone can be between us and our server and presents any certificate that is not signed by a respected certificate authority. It will basically be a self-signed certificate. So I do hope you see the importance of this and the importance of understanding that once you modify source code or modify code that is related to the security of your application, you need to be careful and you need to understand what you are doing. What we will be doing is, instead of saying that we will accept every single certificate that the app receives, we will instead say we will only accept a very specific certificate. We will only accept the certificate generated by our Burp Suite client. And to do that, what we need to do is we need to load the certificate. So as you can see, I've added these certs in the assets folder. And these certs are actually the old ones. We are going to go through this entire process together. But we load these certificates, and then we get the security context. And then on that context, we set a trusted certificate. So if we go to trusted certificate, and we scroll up, set trusted certificate, you can see that this is a file, and it's a path to a PEM or a PKC12 file. And if you remember, we briefly discussed each of these, a PEM file and a PKC12 file. And if we look at our current file that we have, you can see that it is a .dir file. And a .dir file is the same as saying a .crt file. Let's keep it as .dir. So basically, we either need to generate a PKC12 file, or we need some way to convert our dir file to a PEM file. So I prefer going the route of converting the dir file to a PEM file, because if you go to Burp Suite, it's quite easy to actually export a certificate and private key in PKC12. So if we do this, then we have the file, and we would generate a password for this, and that password would be associated to opening this package. This is essentially like a zip file. But the problem with this is we will now essentially be packaging our application with a certificate and a private key. And it's never a good idea to package your application with a private key. If someone has the private key, then they can decrypt anything that is encrypted with the public key. And the public key is contained in the certificate. So what we want is we definitely want to have the certificate in dir format, and then we will take the dir format and convert it to PEM. And that is quite easy to do. So we're going to go to our little terminal over here. As you can see, we have the certificate in .dir, and we're just going to go to the most common OpenSSL commands. And OpenSSL is a utility for Unix systems. I'm pretty sure you get it on Windows as well. Just Google how to do it if you are running Windows. But on iOS or OS X and Linux, you should have OpenSSL installed by default. And then if we scroll down, you can see converting OpenSSL or converting using OpenSSL and convert a dir file to PEM. Perfect, that is what we want. So we're just going to copy this, paste it in, and our certificate file is in. This will be the file that we go in. Ooh, this is wrong. Ah, no, it's not wrong. Okay, so this is exactly what we want. Sorry for clicking around. So we're going to say burpcert.dir, and then what we want to go out is certificate.pem. And there we have it. We have certificate.pem. And now what we're going to do is in our assets, as I said, these are our old assets or the assets that I use for testing purposes. I'm going to move that to trash, and then I'm going to take that new certificate that we made, certificate.pem, and then I'm going to drag it into this folder. And as you can see, this is a base64 encoded, and it's ASCII. It's not binary. And this is basically exactly the same as the .dir file. It's just a different encoding. And by encoding, I mean this is using ASCII, and it is base64 encoded. And then in our popsec.yaml, we need to add this as an asset. So I'm just going to add the assets, the certificate.pem, hit save, and then we go to main.dart again. And as you can see, we are loading from assets raw certificate PEM, and then we are setting the trusted certificate. And as you can see, this has a optional password parameter. And if we were loading a .crt file, if we were loading a PKCS12 certificate, then we would need to give it a password as well. But because this is just the certificate, because this is basically just the public key, we don't need to do that. And I believe that is all that we actually have to do. So this is the function that will do it. And now what I'm doing, as you can see, I've marked my main function as asynchronous. And this is also an asynchronous function because we don't know how long this will take. And then I am calling this, here I can actually just say await, add self-signed certificate. And that's fine, that's 100%. But that would mean every time we run this application, it will be added. So if this is a debug build, it will add the certificate. If it is a release build, it will also add the certificate. And there's no real reason that we want our release app to basically allow this certificate to be a trusted certificate. We only want this in debug builds because that is the only time we will actually ever be wanting to proxy our application. So instead of calling it like this, we will wrap it in an assert. And what the assert logic does, it tells our Flutter application that it should only execute these on debug builds. Once you actually make a release profile and it compiles your application, then Dart will ignore anything that's within assert logic. So this is perfect. Now we not only restrict the certificate that we allow, but we only restrict it to debug builds. So this is as secure as we probably can be. So we're going to hit save, going to do a hot restart. So we're going to go back to Burp Suite and let's go and say intercept. And I'm going to make a GET request. And there we go. We have a GET request. Actually, we're seeing a lot of traffic, and that is because of that request to, oh no, that's fine. It should be that. It should be Wikipedia. Yeah, I forgot. We made this GET request go to Wikipedia. Let's send a message and say test 1, 2, 3 and intercept that. And there we go, 1, 2, 3, 4. And test 1, 2, 3, 4. Perfect. So now we're intercepting our traffic. This would still obviously work because, I mean, it's HTTP. The real thing that we care about is the fact that we can intercept HTTPS traffic. As you can see, we're making a request to wikipedia.com and it's http.s, not .s, and it's HTTPS. So meaning our custom certificate that we loaded is working. And there you go. Now we have a fairly secure way of debugging our application and adding a custom proxy to inspect our traffic. I definitely suggest you go read the blog post if you are interested. I go into a lot more detail over there, and it's definitely a good companion to this video. But yeah, I do hope you enjoyed this and I hope you learned something. And if you would like to see similar content in the future, let me know. I definitely want to make more security related videos in the future. So let me know if that is something that you are interested in. But yeah, if you enjoyed this, give it a like and I will see you in the next video. Cheers.